Manometry. A standard technique for measuring pressure involves the use of liquid columns in vertical or inclined tubes. Pressure measuring devices based on this technique are called manometers. The mercury barometer is an example of one type of manometer, but there are many other configurations possible depending on the particular application. Three common types of manometer include the piezometer tube, the U-tube manometer, and the incline tube manometer. So this is the piezometer tube. So what you see here is actually the pipeline. So in 3D drawing, so it will become something like this, a flowing a pipe like this. So water or liquid will flow like this one, and then we connect this pipe with a tube like this. So and then this moving fluid will give us pressure, and this will push the liquid of itself until certain level here. So by using the Pascal paradox and by measuring the height of this liquid, we could calculate the pressure at the center line of at the center point of this pipe. So in cross-sectional area, so mean we cut at this plane, so the diagram will look like this. So normally we will let the tube here open to atmospheric pressure. So how to measure the point at point A here? So we start by using the idea of the Pascal paradox. So means that because all of these is the same liquid, so we draw a line here. So and then we could say that on the same level the pressure is remain the same. So means that we could write an equation PA is equal to P1, means pressure at point A here is equal to pressure at point 1, and then pressure at point 1 here is equal to the rho GH of this liquid plus the pressure that occur from the air, from the gas. So the pressure of liquid can be measured by using the idea of rho GH. So we have the rho G and H. So because we assume that the liquid here is gamma 1, so gamma is rho G, the specific weight. So we have a rho 1 G and H1, and then we add with the P ATM. Because in this open surface, the free surface, so the liquid interact with the atmospheric pressure. So we could write as this one. So means P A is equal to rho 1 G H1 plus P ATM, and then we assume that P ATM here is equal to 0 because we are calculating gauge pressure, not the absolute pressure. So we could simplify the equation of PA here is equal to rho G and H. So this is the piezometer tube. So the second one is U-tube manometer. So it's look like this one. So because we have a U shape here, so we call it as U-tube manometer. And the different this circular diagram is actually reflect a pipeline like this, and then we connect with U-tube like this one. And then the difference between U-tube manometer and piezometer here, the U-tube manometer will use extra or another one more type of liquid here, another type of liquid here to balance the pressure. So means that for U-tube manometer, it can measure higher pressure compared to piezometer tube. Okay, usually the liquid that we use here is called the gauge fluid, and it will have higher density compared to the liquid that flow into in this pipe. So and then we start our calculation. If we are to measure the pressure at A here, by drawing the Pascal paradox lines. So it is worth for us to draw a Pascal paradox line here, because for this one means the borderline between the gray and the blue liquid here, so it will create the Pascal paradox ideas. So mean this is the same liquid, so and then when it stay on the same level, so the pressure will remain the same. So means that from this line, so from this line we could write as P2 is equal to P3. So and then for P3 here, so this is P3, we could write as rho G, so rho 2 G and H2 plus PATM. So and then for pressure at point number 2 here, so we could write as P2 is equal to rho 1 GH1, so means that the pressure until this side, so and then we add with the pressure at point number A, so we add with pressure A. Okay, so here in this side there are no PATM. PATM is not exist. Why? Because there are no open surface that could lead atmospheric pressure to interact with the liquid. So however, at this point we have the atmospheric pressure because it is an open-ended, and the atmospheric pressure is contacted or push the surface of the liquid at this open end. So means that please do not add an atmospheric pressure at this equation. So and then you have three equations, this equation, this and this. So and then we could substitute the value of P3 into this one and P2 into this one, and finally we could say that the pressure for A can be calculated as PA equal rho 2 GH2 minus rho 1 GH1. This is the third type of basic manometer. It's called the incline tube manometer. So the purpose of incline tube manometer is actually to give us more accurate value of pressure, because normally if we have a vertical tube like this, so the meniscus of liquid, okay, will lead us with to some error. So to prevent this one, we use the incline tube like this, because if the level of liquid change, so the distance of this incline distance is still readable because it is longer compared to the difference of height. So this is the main purpose of the incline tube manometer. However, please bear in mind that the pressure P is equal to rho G and H, means that the pressure only influenced by the vertical height. So means that if you have incline length like this, please do not use this length in your calculation. You must convert this length into the vertical height, whether you are using the theta here or you measure by another method. So the most important is the incline length here cannot be directly substituted into the equation. So and then to solve this problem, so we could start with the Pascal paradox line. So we take the Pascal paradox line at this level. So let's say we have point number 3 here. So and then we could say, okay, this is point number 1. We could say that P1 is equal to P3. So and then we could go P1 is equal to rho 1 GH1 plus PA. Okay, because this is the rho GH1 and the rho GH rho GH1 is only covers until this height. So and then we need to add pressure that acts on point A. So and then P3 here can be calculated as rho GH of this one. So we have the rho 2GH mean L2 sine theta. So and then we plus the pressure of this height. So we have plus rho 3GH3. So because it is only until the B, point B here, so we need to add with the pressure that acts on point B. So we plus with PB. So according to this one, you could see that we have three equations. We have this one, and this one. So we could substitute the value of P1 into this one, and we substitute P3 into this one, and finally we could write the difference of pressure between PA minus PB. K is equal to this term, rho 2GL2 sine theta plus rho 3GH3 minus rho 1GH1. So this is the basic example of measuring the pressure of incompressible fluid. Means the pressure occur for liquid. So and then please do not remember this equation, because every time you solve a problem for pressure, you need to start to develop your own equation. So it is not just remember the equation here and solve the problem. So and then in real application, okay, sometimes we use a Bourdon tube gauge, pressure gauge. So it looks like this one. So what you need to do is you just plug in this tube into any gas or any liquid, then you could get the pressure value. So the mechanism is something like this. So we have a C-shaped hollow tube. Okay, so and then normally when we put pressure into this tube, so this tube will try to expand itself. So when it's moved, they will give us a motion here, and then it will create move the dial, and we could read the pressure. So for electronic device, by a small movement here, so we have LVDT. So if this C-shaped tube move a little bit, so it gives us some movement here, and then the electronic device will detect the movement, and then the electronic device will give us the amount of the pressure.